I've got here is a Leadshine Closed loop hybrid servo stepper motor system, courtesy of Gary at Zapp Automation. As you can see there, it's quite a nice little motor, around about 2 Newton meters. Little encoder on the back, number 23. Leads to a lovely little drive, Leadshine HBS 57. Little diesel connector that leads back to the encoder. Your motor wires here and your signal wires at that side. I've just got it running on a little test rig at the minute. It's a 50 volt drive, but I'm running it on 40 volts. Give myself a bit of safety margin, don't want to blow it up while I'm prattling about. It's running through a smooth stepper, little simple bob. Now I've got a bit of test code in Mac. I'm just going to run it through some speed changes. I'm going to run it very slow at first, just to show you how smooth the motor is. And when I say slow, I mean ridiculously slow. F5 it's going to start at, which you'll never run at that, I'm pretty sure of that, but it does show you just how little to be honest, in my opinion, no notchiness. And it's very smooth all the way through its range. When it's stepping up in speed, it just steps up really smooth. Very nice, very nice. Before I do that, I'll just explain this shaft. 1 revolution of this shaft will equal 5 on my XDRO. Also, you'll hear a notchiness, clunky notch. That's this pulley slipping on this shaft. There's no flat spot on the shaft, and the grub screw is a tiny little screw, and there's a little bit of slippage. The main shaft's okay because the motor's got a flat spot on it, so that's fine. Before I go any further with that though, I just want to show you this. At the minute the motor's powered up, the drive's powered up, everything's powered up. If I grab hold of this shaft and turn it, which by the way takes quite a lot of force, I've got to grip this really hard and quite a lot of force is going on this to make this do this. It's ripping my hands to pieces, I'll be honest with you. Then I turn the shaft, you can see it's just springing back. The drive and the encoder work together to bring it back in position. That's the pulley slip in there. No matter which way I turn it, in fact I've got a rag here that I'm going to grab hold of it with, save my hands. No matter which way I turn it, it will just spring back into position. And, well, too bulky that, but if I grab it, pulley slipping again. If I grab it and I hold it, it's fighting me all the time. It's fighting to get back into position, and you can hear it probably in my voice, having to twist very hard to make it do that. Now, if you imagine that's on a Z-axis, an heavy Z-axis, it's just going to take it back to position horizontally, and someone's to lean on it or push on it, it will just go back into position. It will just go back to where it's supposed to be, and it just won't move. And that, I say, it doesn't matter whether you're one direction or the other direction. It doesn't matter. Now, I can fault this. If I hold it for too long, I will be able to fault it. I'm not going to do now. I might do it at the end to show you, but not now. But what happens if you look on the drive has got an alarm signal somewhere there. There it is. Now you can send that signal back to Mac or your control system to stop the software running, to stop your code when the drive faults, which is a very handy thing to have. Like I say, I will try and show you that at the end if I've got time. I've only got 10 minutes of time on this camera. By the way, it's a mobile phone camera, so that's why quality's a bit crap. Right, I'll set the code off running. Oops. Right, as you can see in Mac it's running and the shaft's turning. I will try and show you how smooth it is if I can hold. Now that's F5, that's just a ridiculously low speed. for people that want to run like camera gantries and stuff like that, this thing's fantastic because it's so smooth. Now look, if I stall this, which I am doing there, you can see the grub screw. I'm stalling it, I'm holding it, it just jumps back to position. Now as the lines come back round to line up, I'm going to pull out to try and show you the lines I'm marked together. There you go, and you'll see when it gets to X5 the line should line up, the speed will change up to 10. There you go, and it'll do that, it'll change up 10 every revolution. But in the meantime, I'm going to grab, I'm going to twist, and I'm going to push in all directions. That's like pushing it forward there, which an heavy gantry, it would simulate an heavy gantry running on. And again, if I pull back out and let you see, hopefully be visible. There you go, everything lines up, kicks up in speed. And it's just going to run through a bit of code doing this. There is one point when the speed doesn't. But if I go in again and show you the smoothness of it, hopefully. This camera's not showing it very well. And the speed change up. And again, exactly on mark. And again, grab hold of it, stall it, do what I like to it. And it's just going to line up. The speed will build up quite a bit now. It'll go to about F4000 and then back to 0. As you can see, if I get back on it, pretty much, well, not pretty much, exactly back where it started. That's with me grabbing at the shaft, stalling it countless times. That must be several, what, maybe a couple of hundred steps or more out of position there, or micro steps. Certainly a lot. You'd be well out if it was a normal stepper. Now what I'm going to do now, camera will wobble a bit, but I'm going to do an MDI, and I'm going to do it X59 F100. I'm doing that just to stall the drive now. You can see it's going round, and you'll see I grab hold of it and I'm holding it. There you go, and it's faulted. There's no drive now. The drive has gone into fault, look. And the arrow on Mac is still running. Now if that alarm signal there was connected to Mac, that would have stopped at the same time the drive faulted. Now to get this powered back up, I've got to reset the drive, which I'm not going to do now, but it gives you an idea of how good this system is. Absolutely fantastic. I cannot, no matter what I do or try, I cannot make this drive lose position. I can fault it like I've just shown you, which takes a lot to do, and when that's coupled to a ball screw or something, the mechanical advantage is going to be massive. All in all, very good. Very impressed with it. There you go. I hope that helps someone. Cheers.